things. At the outset, on behalf of Indian Geotechnical Society, Bengaluru chapter, I extend a warm welcome for today's event. This is a Professor T S Nagaraj Memorial Lecture. This is 7th in series since 2010, and we have today the speaker, Professor T G Sitharam, Chairman of ACTE. We are really proud of you, sir, holding the highest office as the Chairman of ACTE. Welcome you, sir, on behalf of chapter. Thank you for accepting to deliver this lecture. We also have Professor Jayant Kumar, who is the chair in charge of Department of Civil Engineering, Indian Institute of Science, Bangalore. I welcome you, Professor Jayant Kumar, for this event. We also have Dr. Anil Joseph, President, Indian Geotechnical Society. Welcome you, sir. Thank you for joining us. I will extend a warm welcome to all our chapter members, senior members of the chapter, our colleagues. Also extend a warm welcome to family of Professor T S Nagaraj. His daughter, Srimati Arati, is joined. Welcome you, madam. We also have participants from different parts of the country as well as few from abroad. So I welcome each one of you for this Professor T S Nagaraj Memorial Lecture. Before we start the event, I have just a few formalities to begin with. I now invite Professor Jayant Kumar to say a couple of words on this event. Over to you, sir.
Thank you very much, Dr. Parthasarathy. Am I audible? Okay, fine. Thank you very much.
Yeah.
All distinguished delegates of Indian Geotechnical Society, all my senior teachers here, I can see Professor Subbarao, my supervisor, and Professor Sitharam, Chairman, All India Council of Technical Education, distinguished guests, and all my student friends. First of all, welcome to this lecture. Before we start the lecture, I see the development taking place in not in our country, everywhere. 120 years back, I think we are unable to fly. And about 30 years back, we are unable to talk so freely with each other in different parts of the world. So call used to be very expensive. Telephone used to be very expensive. So that shows perhaps development is taking place and research and experience of all people is contributing a lot. But at the same time, whenever any natural disaster happens, we are all aware that just 2 days back, we have the disaster happening in Turkey and Syria, where at least more than about 25,000 people have lost their lives. So that shows perhaps still we need to work a lot in order to do something useful to the society and to the people who are going to come in future to this planet. Now, when I read the lecture topic of Professor Sitharam, I was very impressed. I have never been to Ayodhya. So I thought this is going to be a chance to maybe get a glimpse of the temple which is under construction, and Professor Sitharam is going to throw some light on it. And something about our geotechnical society. I think our society is very, very active, contributing quite a lot. Bangalore chapter is very active, although I'm not active. But Bangalore chapter is very, very active. And my best wishes, I won't be taking too much of time, and I would wish that we should start the lecture and we should hear the expert knowledge of Professor Sitharam, who will enlighten us with and will take us to the Janmabhoomi Ayodhya temple. Over to Dr. Parthasarathy. Yeah, thank you very much.
Thank you, Professor. I'll just give a brief about Professor T S Nagaraj before we go to the next topic. Professor T S Nagaraj was born in Mysore district on 3rd November 1936, and he was the son of Dr. T N Sitharamaya and Srimati Sarojamma. He received the degree of Bachelor's in Civil Engineering from NI Mysore in 1959 Master's in Geotechnical Engineering from Indian Institute of Science in 1960 and PhD from Indian Institute of Science as well in 1967. He was awarded the DSc degree of IASc for his contribution in research in the year 1992. Professor Nagaraj joined the Indian Institute of Science as a research scholar in 1961. He continued at IASc in various positions and elevated to full professor in 1984 and chairman of Civil Department in 1987. So he formally retired from IASc in the year 1997, and he was an adjunct professor at University of Massachusetts, USA for about 4 years. So Professor Nagaraj has made significant contributions in the development of basic framework for analysis and assessment of soil behavior and proportioning concrete mixes. The approaches developed were innovative, ingenious, and simple to use in engineering practice. So these are timely when fast-track development of infrastructure projects is inevitable. Professor Nagaraj has supervised about 17 PhD programs. He has authored and co-authored about 300 technical papers, of which 160 on referred journals and 3 books. Professor Nagaraj served as visiting professor in a number of foreign universities and has delivered lectures in more than 25 universities and R&D establishments in various parts of the world. Professor TSN has been awarded a number of awards, including the IGS Kukalman Award 1991, CBIP Pandit Jawaharlal Nehru Birth Centenary Research Award in 1992. He has been the Indian Geotechnical Society Annual Lecturer in the year 1993, elected Fellow of Indian National Academy of Engineering, Fellow of Institution of Engineers, Honorary Fellow and elected member of Executive Committee of the Indian Geotechnical Society, New Delhi. So he was our beloved professor at Indian Institute of Science. Many of his students also have joined this event. So today's lecture is being delivered by Professor T G Sitharam, which is 7th in series since 2010. So before we invite the speaker, so we will call upon our President of Indian Geotechnical Society, Dr. Anil Joseph, who joined us to say a few words. Over to you, Dr. Anil.
Yeah, good evening, Partha, and all the geotechnical fraternity assembled in this meeting. It's a great privilege for me to join in this program, and especially when the Indian Geotechnical Society is celebrating its 75th year of formation here. And T S Nagaraj was a great contributor to this Indian Geotechnical Society, serving as the executive committee member and a lot of invention in the field of geotechnical engineering from his side. Today, we have a very excellent lecture going to listen from our own AICT chairman and our own pillar of strength in geotechnical engineering, the total geotechnical solution TGS will be delivering on a very important subject, the foundation of Ayodhya Janmabhoomi, and a very challenging thing, because once the project was launched, it was quite confusing that what should be the foundation. And the PMO office is especially delegated a select few of the best brains in the country to come up with the solution to this problem. And today, this August gathering will be able to listen to that. Many of our luminaries are here. Subbarao sir, Srinivasamurthy sir, Shivkumar Babu sir. I humble in front of all these dignitaries of geotechnical engineering and wish all the very best for the program. And also, I would like to add one more point is that our 50th chapter of Indian Geotechnical Society will be opened at Mysore on February 23rd, from where T S Nagaraj sir has done his studies. And it's a great pleasure for me to announce that. And I would congratulate SK Prasad and team for making it happen. And wish to listen to T G Sitharam sir for this very important subject, which is a national level important matter. Thank you, Partha Sardi, for giving me the opportunity.
Yeah, thank you, Dr. Anil. We are very eager to listen to Professor Sitharam. So again, those who have joined very late, on behalf of the chapter, I extend a warm welcome for each one of you. Just a couple of minutes before we hand over to Professor Sitharam, we wanted to introduce him as though the geotechnical community doesn't require any introduction of Professor Sitharam, but for the benefit of some youngsters who have joined us, so it's our duty to introduce formally. So I request our chapter colleague, Dr. Sumalata, to kindly introduce for the speaker of today's event. Over to you, Sumalata.
Yes, sir. Respected dignitaries, delegates, IGS members, family members of Professor T S Nagaraj, faculty members, researchers, and other participants. A very good evening to one and all. It's my great privilege and honor to introduce the eminent speaker of today's memorial lecture, Professor T G Sitharam sir, who is the chairman of All India Council of Technical Education, AICTE, Government of India. Professor T G Sitharam obtained his BE in Civil Engineering from University of Mysore, Masters from Indian Institute of Science, Bangalore, and PhD from University of Waterloo, Canada in 1991. He worked as a lecturer at University of Waterloo soon after his PhD and later moved to University of Texas, USA, and served as a research scientist during the period 1992 to 94. Later, he joined Department of Civil Engineering, ISC Bangalore, and served as a professor for more than 25 years. He represented as the chair professor of KSIIDC at ISC from 2015 to 2018. He has served as a visiting and honorary professor at universities in countries such as Japan, Canada, USA, Hong Kong, Australia, and China. Over the last 35 years, he has carried out research and development in the areas of geotechnical infrastructure engineering and has developed innovative technologies in the area of earth sciences, leading to about 500 technical papers, 20 books, with the Google Scholar H index of 53 and I10 index of 151, with more than 8,698 citations. He has guided 40 PhD students, 35 master students, and 25 postdoctoral students. He has carried out seismic microzonation of many urban centers in India, including Bangalore, Lucknow, and Delhi. He is an authority on seismic microzonation and site effects in the world. Presently, he is the president of Indian Society of Earthquake Technology and president of International Association for Coastal Reservoir Research. He is the chief editor of International Journal of Geotechnical Earthquake Engineering, USA, since 2010. He is the editor-in-chief, Singer Transactions in Civil and Environmental Engineering, Singapore. He was the editorial member of many international journals of repute in his area of research, like Geotechnical Letters, ASCE, Journal of Materials in Civil Engineering, etc. He has delivered the prestigious Indian Geotechnical Society's annual lecture in IGC during December 2020. He is the Honorary Fellow of Indian Geotechnical Society, Honorary Fellow of Council of Vibration Specialist. He is the Fellow of ACE, Fellow of ICE, Diplomate of Geotechnical Engineering from Academy of Geoprofessionals, ASCE, Honorary Fellow of IGS, Fellow of ISCT, Fellow of ISES, and many other societies. He was the director of Indian Institute of Technology, Guwahati, Assam, for 3.5 years, from July 2019 to December 2022, and took the charge as the chairman of AICTE on 21st December 2022. As the director of IIT Guwahati, he was responsible for creating 5 new schools and 5 new academic multidisciplinary centers at IIT Guwahati during 2020-21, and has taken IIT Guwahati as number 2 institute in citation for faculty in India and a global rank of 41 in the recent QS World Ranking 2022. He developed a strategic partnership with the government of Assam in establishing a medical school and a commitment from the government of Assam to start a state-of-the-art multi-specialty hospital at IIT Guwahati. He is the member of Board of Governors of many NITs, IIEST, NCSM, AICTE, NEACSC, etc. He was a part of an 8-member expert panel set up to supervise Sri Ram Janmabhoomi Temple Foundation laying work at Ayodhya. He also held the position of Director, Additional Charge at Central Institute of Technology, Assam for 1.5 years. Presently, he is the Chairman, Board of Governors at Central Institute of Technology, Assam, and Chairman, Board of Management of Northeast Regional Institute of Science and Technology, Arunachal Pradesh. Presently, Professor Sitharam is the member of Science and Engineering Research Board, SCRB, Department of Science and Technology, Government of India. He was the former Chairman, Research Council, CSIR, CBRI, Roorkee. He was the Chairman, Executive Council of Visvesvaraya Industrial and Technological Museum, Bangalore. He was the Governing Council member of National Council for Science Museums and EC and Council member of AICTE. He is presently the board member of Bureau of Indian Standards and Central Power Research Institute. He is an active member, President's Forum of Southeast and South Asia and Taiwan Universities, member of many scientific committees in international societies of repute and many other associations and universities in India and abroad. He got many national and international awards and has delivered many talks across universities and institutions. There are a lot more achievements of TGS sir, but since time is restricted and everybody is eager to listen to TGS sir, with this short introduction, I welcome Professor T G Sitharam sir to deliver the lecture and share his rich experience.
Thank you, Dr. Sumalata. Without wasting much time, we will hand over the floor to Professor T G Sitharam to deliver this very prestigious T S Nagaraj Memorial Lecture. Over to you, Professor.
Thank you. Thank you. Thank you very much. Namaskar to everyone. Good evening to all of you. First of all, pranams to Professor T S Nagaraj and his family. I was one who was very close to Professor Nagaraj. We had a lot of good time, starting from my master's program at IISc, and then went on to wherever I went, he was there with me. He came to Canada, he came to Japan. So all the places wherever I have visited, he was there. And I spent even there also few nights with him. Dr. Parth Sarathi, Chairman, Indian Geotechnical Society, Bangalore Chapter. Dr. Anil Joseph, President, Indian Geotechnical Society. Professor Jayant Kumar, officiating Chairman of Department of Civil Engineering, Indian Institute of Science. And all my teachers, Professor Subbarao, Professor Srinivas Murthy, Professor Pranesh, Professor, I don't see many of them, but anyway, if I say all the names, that will be very long. So I include all my teachers who taught me, including Professor P.V. Shivapulaya, and all my good friends of Indian Geotechnical Society for almost like 30 years, because I started attending Indian Geotechnical Conference as early as 1986. My first paper was with Mr. K.H. Venkatesh and myself in the Indian Geotechnical Conference in 1986 at Delhi, Conference with a Difference. I still remember that very clear categorically. So pranams to all my teachers at Indian Institute of Science and also at Government BDT College of Engineering, Davangere. Particularly, I would like to remember Professor N. Venkatakrishna Rao on this occasion, who taught me soil mechanics at that time. And also Professor, no more, one more professor name I forgot, who was from Davangere, who was also instrumental me joining Indian Institute of Science. And as you know, my journey was a very long one in the area of geotechnical engineering. And I had a very good number of students who contributed extensively to the growth, what I have seen myself in my career. It's all thanks to all my doctoral students and also many master students I taught, and many interacted with large number of industry experts through continuing education programs. Thanks to every one of them. And today I would like to thank in particular Indian Geotechnical Society Bangalore chapter and also Department of Civil Engineering IISc Bangalore to inviting me for this Professor T S Nagaraj Memorial Lecture, 7th in the series. I also remember meeting Aarti as well as Jyoti, daughters of Professor T S Nagaraj, and namaskar to the entire family, Professor T S Nagaraj. So I would like to with these brief remarks, I would like to start my lecture. This is a lecture which is more than my contribution. It's close to the hearts, close to the people of 1.3 billion people of India. Okay, I chose this topic more because of that, that it is very, very close to the hearts of many people in India. And I thought we will give the status of the present status of the temple. At the end, I will make that presentation. But initially, I would like to give the foundation alternatives, what has been discussed or toiled around for Ram Janmabhoomi, Sri Ram Lalla temple at Ayodhya, Uttar Pradesh. This was a very difficult time. At that time, this temple construction started during the pandemic, years. So I got involved. Next slide, please.
Share the screen, Professor.
Share the screen.
Yes. Go to the next slide.
You are able to see?
Yes, sir. Yes, sir. Continues.
So I would like to acknowledge the contribution of the 8-member committee. Before I even proceed with my talk, you can see many names are very relevant, are very, known to all of you. Professor Raju actually chaired this committee, was a former director of IIT, Delhi, and L&T Geostructure LLP, Larsen & Toubro Limited Construction was a contractor. CBRI and NGRI is the main agency for geotechnical and geological investigations. IIT Madras also reported on the backfill. Argon Engineers, Consulting Engineers and Architect Ahmedabad was also involved in some of the structural part. And CB Sompura, Temple Architect Ahmedabad, was the initial concept given for the temple of Sri Ram Temple at Ayodhya. Sanjars, our own, Sanjars Geotechnic Private Limited, soil foundation experts from Delhi, have carried out the geotechnical investigation in 2 phases. And NGRI, many other institutions in the country have also done the studies. And this is the composition of the committee. Next slide, please. This is, you can see the committee. Committee had Professor Manu Santanam, Deepta Banerjee, former director of IIT Roorkee, AP Mal from, Tata Consulting Engineering, Bhattacharjee from IIT Delhi, myself, Professor Gandhi, also all known to all of you, who is former director of NIT Surat, and Professor Dr. Gopal Krishnan was the CBRI director, former, when I was the chairman of the RC Research Council of CBRI. He was the director, and Professor V.S. Raju was the chairman. So thanks to all of them for their contribution. So the terms of reference to this committee was, I will not read out, you can see very clearly that the terms of reference is review the soil investigation carried out by
Bande.
Evaluation of possibility of liquefaction soil under seismic hazards and suggestion for safeguards, review of precedent of similar structure constructed in the recent past in either India or abroad, review of foundation systems, subsoil conditions, environmental factors, superimposed dead and live loads, underground water current, if any, because it's very close to Sarayu River or Gandaki River in Ayodhya. And with respect to the foundation, there were also some specific issues or questions was asked to the committee. That is, whether there is a need for provision of a diaphragm wall or a retaining wall to confine the entire area and to hold the soil around the temple foundation, and treatment of surfacial fill of soil mixed with the construction debris found in some areas up to a depth of 15 meters, possibility of unequal settlement of foundations, evaluation of shear force consideration of the junction of the pile and raft, review of choice of construction, material keeping in view of desired service quality and longevity, including the use of SCMs, that is supplementary cementitious materials, aging of concrete, consideration of proposed material. So from this, it's very, very clear. It's a very comprehensive committee which looked at many of the things. But in my talk, I'm not going to get into all the details, might touch some of them, but not all. But I'm going to only focus on the foundation alternatives and what alternatives were suggested, what was my contribution in that, why I was a little different than others in that, I would like to say. And also at this moment, I would like to highlight to you that when this committee was formed and this terms of reference was given, L&T had put already the big drill rigs for piling. They have also drilled 4 piles up to almost 18 to 20 meter depth of 1 meter diameter and without any reinforcement. And they have tested both vertical as well as horizontal pile load tests at the site, very close to the site, little slightly adjacent, 10-15 meters from the Garbhagriha. This is the background. After that, this committee was formed. So let me give you the project brief now. Next slide, please. Project brief is, see, this is the Sri Ram temple at Sri Ram Janmabhoomi complex at Ayodhya. One, it is completely constructed. This is what it looks like. A 3D view of the same can be visible. Next slide. Is this the visit 3D view of the temple? Okay, I'm only talking about the temple, Ram temple, not just the entire complex. Please understand, this is about 70 acres, 67 acres precisely initially, but today it has even increased to 100 acres of land. So I'm not going to talk about the entire area of how the Ram temple complex will be built. I'm only focusing on the temple foundation. This temple, this is what you are seeing in the picture. So the project location, next slide, please. Project location is, you can very clearly see, which is about 140 kilometers from the city of Lucknow. Okay, and next slide. So this is the Gandaki River or Sarayu River, what it's called. Both names are very prevalent because this river comes from Nepal and flows and joins the Ganges. And you can see the Ayodhya temple in the blue color in the center, Ayodhya Ram temple. And it is about a kilometer away through the, in between the entire city of Ayodhya is already there, physically there for several, maybe centuries. And next slide, please. So this is the location of the main temple. And you can see, those who are wanted to see where is the Ayodhya itself, you know, in Indian location, you can see in this picture. Next slide, please. So this is what I want you to closely observe. The exact location. If you see the bottom part of the cross section, you can see that square box in green is the temple foundation, probable foundation of the temple. And you can see the cross section along the x-axis, very clearly see the temple is actually on a mound, on a mountain sort of a thing. Okay. And next cross section also shows the same thing in the perpendicular direction. So you can very clearly see that the distance from river is hardly about a kilometer, but temple is actually located on a mound, on the sort of a mountain at that location. Even though immediately next to the temple foundation, about 15-20 meters or 30 meters, the gradient actually changes drastically. You can see in this diagram. Next slide, please. Next. Yeah, you can see the contours here and the temple foundation very clearly marked there. So temple foundation levels also I will talk in the next slide. About at 105 is the ground level. And you can see immediately on the eastern side, on the western side, it is almost like 6 meter drop towards, that is, goes to 99 meter. On the other side, it increases to about 4 meters or 3 meters in the northern side or northeastern side. Okay. And similarly, it is a little bit fairly flat in the southeastern side. Next slide. The cross section, typical cross section of the front cross elevation is shown in the left top figure, and the bottom and the side figure shows the ground floor plan and also the first floor plan and overall plan. I will also talk about this little later in the next slides, please. Next slide, please. Yeah, this is the second floor plan. So the temple has basically 3 levels. Next slide. So you can see the total width of the temple. You can about 116 meter in length and 74 meter in wide. And this is the main temple. And the percotta is outside. And this is the total dimension of 182 meters by 181 meters is the total dimension of the temple. Next slide, please. So now the typical cross section of the temple. So you can see the bottom part of the the center where the Garbhagriha is there, it is with a tower 161 feet tall. And also please watch, 105 is the ground level, but made up level is at the podium level, what we call 111 meters. And the proposed temple level is at 112 meters. That means about 7 meters above the existing ground level. But formed ground level is something like 107 meters. That means even a 5 meter above the formed ground level, the temple level is going to come. So there are a lot of steps to climb on both sides as well as the front. Next slide, please. Before that, just go back one slide. Go back. So you can also see the 3 levels, okay? That is 161 feet, 111 feet, 89 feet, 69 feet, 49 feet. The gopuras for different sections of the temple also varies. Okay? Next, please. So I will not get into the structural details, but the total temple, because it's also very important from this deciding type of foundation. So the pillar connections there is no steel at all used in the temple construction. And pillars and also beams, columns are almost ready-made, and they are simply assembled at the site. And you can very clearly see some copper clamps are been put for the slab connection and also for the beam connection. For the pillar connections, they are basically grooved into the base parts of the pillars. So very, very clearly you can see the cross section A and cross section B. The details are given here. And if some of you interested, I will share the presentation after my talk so that you can take a look at it much more closely. Next slide, please. So this is the owner of the temple is Sri Ram Janmabhoomi Tirtha Kshetra Trust. And the PMC is Ayodhya Management. Temple architect is CB Sompura. Temple architect project title is Engineering and Construction of Ayodhya Complex, Ayodhya. But as I told you earlier, I'm not going to talk about complex, only talking about the main temple. So location is, it's also called as Faizabad, but it is renamed as Ayodhya now. Otherwise, the city is a Faizabad. And total area of the temple is 67.7 acres. From the media reports, I understand now it is close to about more than 100 acres, the same area. Nearest city is Lucknow. Faizabad is 8 kilometers from this area. So contractor is L&T Geostructure. L&T Geostructure is a unique legal business entity who are experts in building foundations by focusing, capturing and building business in the ground engineering segment. So you can very clearly see the way even the contractor is selected is more of a geotechnical structure, because superstructure is almost like assembly.
Recording in progress.
So next slide, please. So this is the geotechnical investigations. Investigation of the foundation system. Next slide, please. I don't like you to read this. The executive summary is not necessary at all, but I just put it for the trace to understand the how this report, geotechnical report, has been prepared, whether it is groundwater or surfacial fill. So what I would like to highlight to you is a surfacial fill about 5 to 17 meter from about RL of 88.9 meters to 90.1 meter depth from existing ground level is the fill, consisting of soil mixed with construction debris, is met. And SPTN values were varying anywhere from 3 to 15, with some higher values in filled up soils. So this is the totally drilling was 15 exploratory boreholes were done, and 3 boreholes to about 60 meter depth, and 5 boreholes to about 30 meter depth, and 8 boreholes to about 20 meter depth. And there is the second level of geotechnical investigation also was carried out at the site. Okay, and one more important information is based on the SPT values, generally medium dense to very dense inconsistency has been described by the report. Groundwater was met at something like somewhere between 6 meter to 17 meter, RL of 98.90.1 meter, varying in the site location. And liquefaction is according to the geotechnical report, where the soils at this site are not likely to liquefy in the event of a design earthquake. So, but this question was again posed to the expert committee. However, the foundation recommendations were, if you look at the geotechnical report, this is from the geotechnical report, that RCC bored cast in situ piles, foundation with reinforced with steel bars and reinforced with fiberglass material, all kinds of things were given in the geotechnical report. Ground improvement shall assist in distributing the load uniformly by varying the spacing between the stone columns. The stone columns were also thought of jet grouted columns and total and differential settlements. Okay, and the interesting part is the permissible total settlement is specified as 12 millimeter with no differential settlement. That means differential settlement of 0 millimeter. So the additional investigations, which is actually not in the same sequence I'm describing you, but when I'm talking about geotechnical investigation, I thought I'll give you the additional investigation also. This is after the committee has been formed. So the additional investigations were from the ground level, the temple area at a higher elevation than the surrounding area. Inundation of the foundation is a rare possibility. So we found that this is located on a mound. In addition, proper care should be taken to drain the rainwater if there is anything. And one single integrated raft is very essential. That is what the discussion. Sequential construction from high load density. I will show you in the later slides how the load intensity is also varying in the temple, the main temple. Okay, and they've done a very interesting analysis. Actually, L&T and TCE have done an interesting analysis. So additional investigations were carried out at the site with several boreholes. I will show you in a little while, and also with regard to the possibility of the existing paleo channels in the area of interest. NGRI did some geophysical testing and also tomography test. Tomography was captured. Estimation of earthquake characteristics, again NGRI did that work, and including local site effects. Next slide, please. Next slide. So these are the borehole location and pile load test locations. Okay, you can see the vertical pile load test was conducted. As I told you, I'm not actually giving you in chronologically because these tests were done before the committee was formed. Vertical pile load test and lateral load pile load test. There are three of them: LTP, VTP. You can see in both the figure on the right hand side. Okay, LTP1, LTP, VTP, VTP2. That is, VTP refers to the vertical pile load test. LTP refers to lateral pile load test. Okay, so there are 4 piles were casted and tested before even the committee got into the site. But the other boreholes, what you are seeing in the temple area, were asked to be drilled later on by the committee. And these were also done by the St. George Geotechnical itself. So there were some trial pits at the site. Next slide, please. So these are very clearly indicates from the trial pits and soil type at the location, we can very clearly see that the soil is, I mean, at least in some of these boreholes, we did not see any of the artifacts or anything, at least when I visited it. So these are the location. Next slide, please. These are the locations of the trial pits: TP1, TP2, TP3, TP4. Okay, next, please. So these are the bore logs of the 7 boreholes, what you seen in the site, and very, very clearly see that 0 to about 7 meters or 8 meters is the fill. In some location, it went up to 11 meters. So, for example, if you can see the second one in the right box, there is a fill, soil fill about 11 to 12 meters. Next slide, please. So the ground level, existing ground level is marked there, 105.17, and these are some of the other boreholes. And you can very clearly actually track near the compound wall, near the Hanumanji temple, and compost the Sitaji Mandir, and where the boreholes show the variation of the fill, which is in the blue colored one, what is shown. So we can very clearly see that the depths up to about 12 meters in some cases. In one case only, it is more than 12 meters. Otherwise, maximum 12 meters, but average something like 7.5 meters from the existing ground level. You got a reasonably good material. Next slide, please. So this is the map of Ayodhya region with deposition of Sarayu River. you can very, very clearly see the meandering scars of the Sarayu River or the Gandaki River. It's also called as Gandaki River. And you can see the cutoff bank. It does not touch this mound at all. The mound was not touched at all. Mound was quite far away where the temple location is located. Sarayu River has a large floodplain with large mid-channel bars and channel meandering with multiple meandering scars within the floodplain. Ayodhya and the temple site is located at an elevated ground. This is what I want you to remember. Beyond the active floodplain. So the floods are not going to touch this mound. The temple site lies adjacent to the cutoff bank to an abundant meander of the Sarayu River. It is a natural depression of a paleo channel near the temple site. Based on this, the committee has asked the NGRI to do the paleo channel analysis for this site. Next slide, please. So this is the ground penetration radar map of the temple site, and very, very clearly shows uneven distribution of buried cultural artifacts and structures. The first one in the right side picture very clearly shows there were a buried well in the site. There is a very clearly a buried well in the site, but it was little far away from the Garbhagruha area. And the temple zone, very clearly, there were several buried wells in the site, but not exactly in that particular location. Until these wells were up to about 30-meter depth, which are identified, including one underneath the Garbhagruha. And that means very close to the Garbhagruha, with the damaged well lining was also been noticed at the site. So we can very clearly see the channels, how it could be below the ground, and in the left side picture. And the GPR data is very, very clearly shows the details of that. Next slide. This is the deep resistivity sounding and electrical resistivity tomography, ERT, was done. And MASW survey was also done at the site. Next slide, please. This is the multi-channel survey survey. Very, very clearly you can see that the soft soil in some locations are up to about 12 meters, maybe some only one or two locations, it may be a little bit of 15 meters. Otherwise, reasonably, they have done up to artifacts about 30 meters depth. The more than 30-meter depth analysis were carried out. This is the multi-channel analysis in the north-south profile of the temple area. And we have shown you the parallel to P6, parallel to the profile at 2.6, also parallel to profile 4 also we have shown. So the earthquake hazard studies, next slide please. With microtremor studies are also done by NGRI. Shear wave velocities are class C and class D as per NEHRP classification. And transfer function reveals the amplification of ground motion in the frequency range of 0.3 Hertz to 4 Hertz. Response spectra was developed with damping ratios of 2, 3, 5, 7, 10, 15% critical damping. And unified horizontal design response spectra, which is shown on the top, as also on the right-hand side, is also clearly developed by the NGRI team. Likely PGA range was about 0.25 G to 0.3 G, but design PGA was 0.25 G, which was recommended. Temple structures are likely to have natural periods in the range of 0.3 to 0.6 seconds. Next slide, please. As I told you, additional geotechnical investigation layout, which I showed you earlier, the boreholes, as well as these investigations where the GPR was done is also marked in this diagram. Next slide, please. So let me take you to foundation loads and foundation alternatives. Foundation loads, next slide. So Garbhagruha has about 40 ton per meter square with different colors which is being given now. Guda Mantapa, the second one is called Guda Mantapa on either side, is about 32 ton per meter square. Rangamandapa, next level. You also notice that I had shown you cross section. You should remember the height of the Gopuras will also change now. At Rangamantapa, it is about 30 ton per meter square. That means the load is also reducing towards from left to right. And at podium, it is about only 18 ton per meter square. So the raft area with fill and the stairs are also shown to the temple. As I told you, it is rising. And so this is the basically the foundation loads. Okay, next slide. So this is a little bit intricate drawing with typical foundation type, Garbhagruha. You can see upper plinth, temple walls and temple columns, sand and soil filling. Some features are also shown in this particular picture. Little more detailed, exactly similar to based on the input what they have got there. This is the earlier, the stone and brick superstructure, excluding the podium and the lower plate. So the next slide, please. This picture again shows the same in a pictorial form, the raft, and you can very clearly see raft and F8, F7, F8 were about 38 ton per meter square. See, there are some areas in middle, F7, between Gudamantapa and Rangamantapa, F7 is there, and you can see that F7 and F6 also, they have shows the load of foundation load of 38 ton per meter square. The F1, the green one, which is a square, which is about 30 ton per meter square. The blue one is 26 ton per meter square, and the orange, the pink one is about 28 ton per meter square. The blue one is 25 ton per meter square, and S1 and S2, which are you can very see the outside, complete outside to the right side, are about 13 ton per meter square, and complete outside green is 3 ton per meter square. Next slide, please. So let me take you to foundation alternative. Foundation of Ram Janmabhoomi temple, considering that the design need to address the design life of 1,000 years of the foundation and structure. Following important requirements of the foundation design. See, even, I mean, for young people who are assembled on this platform, I would like to say, even nuclear power structures, we are going to design only about 300 to 500 years. So, but this temple was in design life was taken as about 1,000 years. So the differential settlements, which are close to zero, which is prescribed at 12 millimeter, ensure safe transfer of superstructure loads to founding strata, vertical downward, upward, and horizontal loads during seismic events, ensure durability of the founding material, whatever material we're going to use, whether it is a pile foundation or stone column, sand columns, or whatever, for the effect of weathering, we should consider, and also against impacts of underground water currents, if any, and at the site. This was the requirement of the foundations of Rama Janmabhoomi temple. Next slide, please. So the temple foundation requirement, as again repeated, allowable foundation settlement should be about 12 millimeter due to temple column superstructure, because as I told you, the column also doesn't have any steel inside. Only some copper clips were given between the slabs and beams, and between the columns, between the pillars, it is only a groove which is connected. So some cement was planning to be used to just to fix it initially. Differential settlement along foundation should be negligible. The foundation alternatives which were considered in the very beginning, raft foundation resting on soil without any treatment, raft resting on piles, raft resting on jet grouted columns, raft resting on pile raft foundation, raft on stone column foundation. See, please look at the pile raft was also been thought of. Yeah, okay, where the raft would be sitting on the ground, transferring some portion of the load, which is a very new type of foundations for the younger people. Raft on stone column foundation, raft resting on improved ground, ground improvement into open excavation. So this is the last option actually, and you have seen already the recommendation of the geotechnical report, and I will also talk about the experts committee also to create a confinement around, because it was they were observing it was an amount that maybe there is a good chance of it coming down. So they wanted the thinking initial thoughts were to create a confinement around main temple for restricting outward flow of soil, and for additional lateral restraint, a skirt wall or a diaphragm wall was also being planned. Shall be also introduced all around the periphery of the main temple foundation. Next slide, please. The foundation alternatives were shown here to you. Just as the first, I would like to show you the leftmost is the diaphragm wall all around, and the rightmost also. And in between, you know, the alternatives, whatever I showed you, the pile foundation, the raft foundation, and also above the raft also, please watch. Above the raft also, there is a foundation because the difference between the base level of the temple and the natural ground level or ground created ground level is quite a lot there. So that is about 3 to 4 meters, 5 meters. So that was also been with for some of the pillars. This step foundations are also been provided. Next slide, please. So just to show you in a three-dimensional way how it was. Diaphragm wall and piles in the raft, just to show you pictorially, and you can very clearly see the pile spacing and other things were also varied, and a lot of analysis were done by Lanti and Tata Consultancy Engineer and also many others involved in the project before even the committee got into it, and they have looked at this, and the problem was, you see, the total settlement was coming. Next slide, please. Next. Was about 114 millimeter with all these stone columns or raft or pile foundation, all the alternative. There are several analyses. I'm not going to go into the details of these, but it was a large settlement. It's not 12 millimeter. Next slide, please. Next, please. So the pile testing and simulation, we can very clearly see here. One is LTP1, LTP2. And modulus of rupture was 3.5 megapascal, and we can see that the piles failed drastically. Okay, and then this is the vertical load piles. They are reasonably took more load. Actual vertical load was 210 tons. Corresponding settlement was only 2.7 millimeter. Actual vertical load on the pile was about, in another test, was 210 tons. Corresponding settlement was only 2.5 millimeter. So this is the lateral load diagram. Next slide, please. Yeah, this is the vertical load piles. Yeah, next. Yeah. Next, please. So again, I'm showing you the locations of the vertical pile load test and the lateral pile load test in plan. So there are 4 of them. LTP1, VTP1 at the top, and in the southern part, LTP2 and VTP2. Next slide, please. So the committee was also looked at excavation, and if it has to be done, how the excavation will look like. Okay, and if it has to be excavated up to whether it is 7 meter or 12 meter or 15 meter. Okay, there was a lot of debate on that. And next slide, please. So this is if it is an open excavation, this is the way we have to step the excavation for the entire area, and the three-dimensional view is shown in the right side to you. And the left side, what is shown, the cross section. Next slide, please. Yeah, you can see the slopes of 1 and 2 were adopted, and with a berm at every increment. And this is excavation layout for 12 meter deep excavation. But many alternatives were also worked out. Okay, for 7 meter, 8, and then maybe about 14 meters also. This is the 12 meter deep excavation cross section. Open excavation. So if it has to be open excavation, so this was the worry. What do we do with the entire fill, because it was considered as a loose fill and it is not in a position to reuse, because I mean whatever information we had is only through boreholes. Please remember that. We had whatever information, what is the type of soil, borehole, and the trial pits were very, very shallow, very close to the ground. So we didn't have a very clear information about what is there below, whether it is the bodies, dead bodies, or whether it is some artifacts or some wells. Wells were indicated in 1 or 2, 3 locations, as I showed you in the GPR and MSW, but only one well was actually physically seen by the team, where some brick lining was found. Next slide. So this is another typical section at 88 and BB, which is shown here. So you can see one is from the left side, one is from the right side. So you can very clearly see, if you go back to the top, just go back 2 slides, Sandeep. Yeah, no, this one. If you see the cross section AA here is horizontal, BB is vertical. So we can very clearly see how the excavation would happen, and if the soil has to be disposed of, where we should dispose. It's a large quantity of soil. It is 12 meter depth. Go back. So these are all some of the questions. Then, the entire area had luckily 67 acres. Even if you put the entire volume of soil excavated, would be enough to fill up the area, maybe not even 300 millimeter or 400 millimeter for the 67 acres will work out. If you remove the soil and refill with some other new material. I was of the opinion initially, the same soil, if the soil is uniform, could be utilized by recompacting it to maybe modified Proctor. That was my gut feeling. But anyway, I will also tell you my story little in next slides. Next slide, please. Yeah, these are some of the slope stability analysis for the 1:1, one vertical to one horizontal for each of the 3 meters, depth up to 12 meters. So the slope stability was done using Talron. This is all done by them only, by the L&T group. So the factor of safeties were reasonably good, 1.54, even with 1 vertical to 1 horizontal with berms. So the average slope was 1 and 2 basically, if you look at for the entire 12 meter depth. Yeah. Go to the next slide. So you can see 12 meter with 3 berms, 2 meter wide at 3 meter, 6 meter, and 9 meter depth. So this factor of safety was worked out to be 1.24. Please remember, this is only during construction. This is a temporary construction because once it is done, we are going to fill it back. From the above results, without considering groundwater table, the factor of safety against slip stability was minimum was 1.24. What was decided by the team was 1.2 was enough. So it is much more than that for the temporary construction when there is no groundwater table. So why I said this, this is very important to understand. And again, whatever I'm showing you, it is not in any order of, I've not gone in order of what discussion took place and how it was done, but I'll just show you pictures and then, I'll put on my story. Next slide, please. Open excavations were started doing, you can see that here. And how this was decided, I will also tell you, maybe after 2 slides, I will talk about why the open excavation site was prepared and preferred at the foundation preparation. So you can see now the exposed piles also, which were tested at the site. Okay, we're standing tall in those pictures. And you can see how the excavation was continued, creating berms and the slope of 1 vertical to 1 horizontal. Next slide, please. Yeah. So this is where I would like to tell my story, ground improvement versus hybrid foundation and deep foundation. The concept was justified taking into account the ground condition, structural and serviceability requirements of the buildings and economical factor, both time and cost. See, one group in the committee also felt that there is a need of improved ground between 7 to 15 meters and about 7 meter depth or 15 meter depth. Okay, it's not that because 7 meters in more than average, it's good. And below that, natural ground is reasonably good. And there is not much of a water table effects there. And the raft would anyway at the level what was decided at 105 meters. Okay. So while deciding this, the committee actually was sort of divided. One group said, we'll use the stone columns. And another group said it is open foundation. So I was also choosing an open foundation. I was the party to open foundation. The only one reason it occurred to me, when pile itself with a concrete could not take the loads, settlements, definitely stone column and our stand columns will not take that settlement. Settlements will be in the range of 100. So because 100 meter was done with a pile and a raft kind of a foundation, and which is a huge settlement, which is not acceptable. That's why the committee was formed. So I was telling, even if you use a US technology with bottom feed technique of the stone columns would not give you that satisfaction in terms of settlement criteria. So my gut feeling, and I told the committee and also told the temple trust very clearly before deciding I would like to visit the site. And it was a pandemic period. Please remember, it was sometime in July of 2020. They asked me whether I would be willing to go there. I said yes. I took a chance and went there, had a site visit, looked at it. I was much more convinced after visiting the site visit that open foundation is quite feasible there and would be a very natural alternative. And I mentioned that in the several committee meetings. And luckily, one of the person said, let us explore one of these, actually, Swami, who was involved with Akshardham temple in both Dubai as well as in Gujarat, who told us, let us excavate up to 7 meters. And if ground is not very good at all, then we will think about an alternative. So in that way, they took a decision to go for an open excavation and as a group, and they went ahead with the open excavation. And I will tell you the success story of that in a little while. So there was a letter, and after visiting the site, I gave a detailed report of what I found and what furthermore investigations are required. And some of those investigations were done, like what I told you, the earthquake and seismic studies, and then NGRI study, all then was done later, and additional boreholes were all done later after my site visit. Next slide, please. So what do we fill back? Because they were thinking that this fill would not be very good. So there was a lot of discussion on engineered fill, whether should have a soft rock like characteristics. That is what Manu Sitharam gave a report from IT Madras. Engineered fill should have a soft rock like characteristics, then only it will be uniform. And many of us also sort of agreed, but I was of the opinion that making a rigid foundation is not a very good idea. I thought because we are not going to have a sort of a machine foundation type of problem here, but somehow I was saying even using the existing soil, which is, if it is reasonably homogeneous, removing the artifacts and bricks and other things, can be possible recompacting to modified fractal. That was my report, which I gave to the committee mentioned. But however, there were other discussions, well compacted granular fill, well graded cementitious compacted granular fill, and roller compacted concrete were also discussed. And there was a study of the different temples across India and also elsewhere in the world. What is interestingly, we found out none of these temples which are constructed, which survived also, even including Rajaraja Chola's temple, had never had any adopted any deep foundations. So deep foundation or even ground improvement of nature of stone columns or sand columns were also not been adopted. Some of them had like 1,000 pillar temple had some boxes filled with sands, box foundations were done. But otherwise, there was a detailed survey done by the, I think, TCE, not the consulting engineers, on the different temples and type of foundations available. And it's a very interesting learning experience for us on that side as well. Then RCC was designed and proportioned at IT Madras. Testing was also done before using the ingredient source from the site, like 250 millimeter layer of thickness was recommended for the raft, and soil at the base should have an SPT greater than 40. So they had agreed whether it is a soil or engineered fill should have a value of 40. Next slide, please. So foundation alternative suggested by the expert committee was two. Very clearly, I just taken out the recommendation from the report itself. One is option one, ground improvement by vibrostone column. This was the first option by half of the committee members for a compaction of the fill layer, vibrostone column for dry bottom feed method, which is a good option. This is a well-established technology used worldwide, including India. This should be done for the entire footprint of the temple plus a minimum of 20 meters beyond the temple perimeter. A full-scale field trial shall be carried out, comprising of large footing load test to establish the design parameters, spacing, depth, and area replacement ratio to achieve the required improvement. The next one is the open excavation of the engineered backfill. This was the recommendation of the committee. Please note that it is not the backfill with the existing soil. In this method, open excavation is carried out up to the bottom of the fill. The natural strata is well compacted with vibro rollers, dynamic compaction. It is followed by placing engineered material in layers and compacted by suitable compacting equipment. So I am not going to read this entire thing. Well engineered, proved through full-scale field test, trial, and well executed, both the options will meet the foundation requirement. This is the total recommendation was given. It is important that both the options are engineered by the EPC contractor. Their confidence to execute these options is crucial. So we also mentioned that the contractor should, luckily here, L&T Geostructure was an expert on these things only. Concrete can be designed for a very long service life, 1,000 years or more, because if concrete has to be used in the base, roller concrete with a low cement ratio, then it has to be with a high degree of probability. Next, please. So this is again reminding you the committee composition. This is the report of the committee. It is not by me. Next slide, please. So on 29th December 2022, Professor Raju actually visited the Sri Ram Mandir under construction. And this is the post-open excavation and backfilling. Okay. So finally, the post-excavation is done up to 12 meter. The story is up to 12 meter they've excavated and refilled with sort of a low roller cement concrete, okay, as recommended by IIT Madras. So Professor Raju visited on 29th of December 2022. And he sent an email to all of us. He says visit was truly exceptional, both technical as well as spiritual. It is remarkable the way 12-meter deep excavation has been executed in a very short time span. The team deserves a very high appreciation. And also he goes on saying, and I was apprehensive of the latter option of open excavation, mainly because of my concerns with regard to open excavation in a fill. Fill behavior is not predictable. But I have the opinion these vibro stone columns or stone columns are also not of the good opinion. That is why I said the settlement observation measurements showed only 4 millimeter. When he went, the settlement observation were also told when given to him, and he has written in his email. These measurements confirm that the foundations adopted are adequate, satisfying all safety and functional requirements. Between the two options of ground improvement by vibro stone columns and open excavation backfilling, as I told you with engineered material, the latter has been chosen. That is open excavation up to 12 meters. I was only apprehension about up to 7 meters. I said 7 meters is good enough. Afterwards, whatever settlement will happen, it will happen much before the foundation of the temple will come in. Okay, and that means when we start assembling the temple, the settlement would happen. The open excavation, because this is not a clay, so the open excavation revealed artifacts, definitely dating back to thousands of years, which would have been lost in the ground improvement option, which would not have known at all. But now it is all kept in a museum. So next slide, please. Very recent story of the progress of temple construction I will share, but this is my last but one slide. So rare stones reach, you have seen all these in the news media. I just tell you, the idols would be carved out of the Lord Ram from the 2 rocks which are found in the Gandaki River at a place close to Saligrama on Muktinath, place of salvation. And many of us actually at our home, we keep Saligrama and perform puja for that. You remember, that is from Nepal, of Mustang district. And this is the one stone of that. Similar one size stone is coming for Ram and Sita and also the other statues. The next slide shows the video. I'll just show you, it is a 30 seconds video. So next slide, please. So the temple is in construction, and all of you have seen that it will be inaugurated in January of 2024. So exactly about 11 months from now. And I would like to thank every one of you who has contributed, and especially to my teachers, including late Professor T S Nagaraj. And this is our visit. Myself and my wife visited the site in December 2020. And the green enclosure, what is there behind me, is the Garbhagruha of the temple. This is the right side picture is Hanuman Gadi. And the below picture, when we went to the site, there were huge drill rigs were present at the site. And where we are standing and looking at is the pile foundations, which are tested for vertical and lateral loads. You can see those piles, which are 1 meter diameter. Thank you very much. Dhanyavad, Namaskar, Jai Bharat, Jai Hind. Namaskar.
Thank you. Thank you, Professor. Indeed, all of you will agree that it was a very fantastic presentation, particularly highlighting the project of national importance and also the geotechnical aspects that has gone into this project. We are extremely happy, and thank you, Professor, for sharing with us the technical aspects of this temple in this presentation. So we are already running out of time. So therefore, I kindly want to conclude this session by requesting our chapter colleague and secretary, Professor Anbalgan, to propose a vote of thanks. Professor Anbalgan, over to you, sir.
Yeah, so good evening to all of you. So I all agree that so we had an excellent lecture by Professor T G Sitharam. So Professor Sitharam actually made significant contribution in the country level. So where he was a pioneer to introduce the change in the consideration of earthquake, soil effect in the name of microzonation. And then this work, other than him, nobody can do. So I thank him to sharing his experience and sharing all the geotechnical details, enlightening all the youngsters so towards the geotechnical things. So then I thank Professor T S family. So they are kind enough actually to host this lecture in the society, and also they contributed to the institute. So it has to be remarkable. So they contributed the best thesis award every year from the institute, which is 1 lakh cash actually award. So I thank them for extensive support to the society as well as the institute. I thank the Department of Civil Engineering, so who is continuously supporting and hosting the Indian geotechnical lectures and then activities. So I thank Chairman in charge, Professor Jain Kumar, and then the IGS President, so Mr. Anil, and also all our senior colleagues and IGS members, and also all participants. So without you, this program may not be success. I thank all of you. So I thank one and all. So thank you very much.
Yeah, thank you, Professor Anbalgan. And with the seeking permission from Professor Sitharam, the recording of which video will be sent to him. After his consent, then we will upload it into the YouTube channel. So we will share the link then for you to watch in the future date. So with this, we conclude this session. So again, I thank each one of you for joining us. Thank you, Professor. Thank you, all of you. Thank you.
Thank you.
Thank you. Namaskar.